Hi, my name is Denomi, and this is handout number 12. So in order to do the first question, we first need to find out the values of int low and int high. Int low equals 0. Int high equals a length minus 1, which is just the final array, which equals 12. Now knowing this, we know that the array is size 12. So the first step of this problem, we need to set up the while loop, which is while low is less than or equal to high. Because what a binary search is we're cutting the array in half, essentially. And if low is greater than high, that means we've already searched through the whole entire array, which means we return -1. Now we need to set up the actual binary search. Now in order to set up the binary search, like we said, we need to cut the array in half. So low plus high divided by 2. And what this essentially is for the first search, we need to first figure out the value in the exact center of the array, and whether or not that value in the exact center is less than or equal to the current value we are trying to find. If it is less than, we will search on the left half of the array. If it is greater than, we will search in the right side of the array. By starting out with this value, we start out with 12 plus 0 divided by 2, which is A6. It will check A6 and check if 31 is greater than or equal to the value we are trying to find. If AI is equal to X, that means if A6, if we are trying to find 31, if A6 equals 31, then we return I, which basically means that it was found in the 6th part of the array, in the 6th count of the array. If AI is less than X, that means we have to search in the right side of the array. So if we are searching for 100, if 31 is less than 100, we need to search in the right side of the array. Meaning that low equals I plus 1. Yes, low equals I plus 1. And now keep in mind that the low will increase in value based on what the I is. So if the I was 6, the I will start out as 6 plus 1 be 7, low will now be 7, which means we will now be searching in this half of the array. Now else, high equals I minus 1, because if it is lower, so let's say we were searching for 9, if 31 is greater than 9, then we need high to become 6, and we need high to become I minus 1, which equals 5, which means we would now be searching from 0 to 5. Now using this method we just created, we need to search for the value of 100. Now using this method, we know that 0 equals low and 12 equals high, and we know that the first value that we are going to find is 6, because 12 plus 0 divided by 2 equals 6. And now we know that now we know the value in the 6th position of the array is 31. Now 31 is less than 100, therefore we will use the low I plus 1 method in order to search in the right side of the array. So low will now equal 7. High will still continue to equal 12. Now 12 plus 7 divided by 2 equals 19 divided by 2, which equals 9.5, which in Java this would just be 9, which means we are looking in the 9th position of the array. Now the 9th position of the array equals 81. 81 is still less than 100, which means we do it again. 10, 12, 10 plus 12 equals 22. 22 divided by 2 equals 11. Now we search in the 11th position of the array. 11, that equals 121. 121 is greater than 100, which means that we use the high equals I minus 1 method. Now, low will still continue to equal 10, but high will now equal 11. No. High will now equal 10, because I was searched in the 11, I minus 1 equals 10. Now if we search in the 10th position, 10 plus 10 equals 20, divided by 2 equals 10, which means we search in the 10th position, 100, and 100 does equal 100, which means we have found 100. Now to answer this, AIs equal these values, which means we first searched for 31, then we searched for 81, then we searched for 121, then we searched for 100. And now doing this again, we need to search for 1 using the binary search method. So we start out low, now using the same chart, high, I, AI, and then value. We'll just type in value for now. Low will again equal 0, 12. We start out with the original method. We start with the original method, 0, 12, 6, equal 31. 31 is greater than 1, which means we'll now search in the left side of the array. Which means high now equals 5. So 0, 5, because high equals I minus 1. 0, 5, which means 5 plus 0 equals 5, divided by 2 equals 2. So 2, we are now looking in the 2nd position of the array, which means we are now looking at 4. 4 is greater than 1, which means we do it again. We are now in the 2nd part of the array, which means 2 minus 1 equals 1, 0, 1. And now as we keep on doing this, we are consistently cutting the array in half. So we search from 0 to 5, and now we search from 0 to 1, 1. So 0, 1, 1 plus 0 equals 1, 1 divided by 0 equals 0, 0. And now we search for the value in the 0th position. So 0. AI 0. This is obviously 0. 0 is less than 1, which means we do the value again. 1, 1. So 0 plus 1 equals 1. 1, 1. The value in the first position is 2. Yeah, 1 plus 1 equals 2, divided by 2 equals 1, which means we're looking at the first position. The value of the first position is 2. 2 is greater than 1, which means we now have to search the value which means we now have to do this method. But if we do this method, 2 is greater than 1, which means the while loop stops and we return -1, which is not a valid case, which means we do not return anything. Now using this, we searched, which means that is the end of the method. Now using this, we searched 31, 4, 0, and 2 before we found our original value, before we found that this wasn't a valid case. So we put here 31, 4, 0, and 2. It was confirmed that was not a valid case. So we write valid case, or we return -1, which is the end of the loop statement.